agreement. Oh, you started it or?
Yeah, I started.
Okay, good.
Weird, I guess the program I use.
Yeah.
The PDF, when it reads into just the, what's it called? The Canvas one.
Yeah.
It doesn't show any of my work, but when you download it, it's on. It's the weirdest thing. I think you said, it looked like, yeah, it just looks blank.
The meeting is being recorded by the host of or a participant. Got it? And I should be recording the meeting also, right? So that one is which one? This button. Record. Record on the computer, yes. Continue. Good. Okay.
That's just weird.
We should ignore that. Let that end. That's mine. No, it's not an alarm.
You just want to stop it or-
No, it will stop it of its own accord. For some reason, I have very large number of spam calls. No, I know how to stop it, but I didn't.
So I found out a good way for me to stop. Was it spam calls on those phones? There's a function that says silence unknown numbers. So if a number that you don't know calls you, just it'll call through and they leave a message. But if it's a spam call,
Mine is, I see, I didn't see that option.
What?
Google Form. This, I think is it 7 now? 7. The last one. Yeah.
I like the A6, like the smaller series.
The smaller series would require my eyesight to be what it was earlier.
I like small.
So there's a fun thing, this on TikTok, but something very useful every time. It was like someone flipped up and it's like, people born in the 90s going into their settings and turning their font size up a little bit. And I was like, get in there.
Oh, incidentally, I was told that fish cake is actually Sean Thompson. So, well, I don't know whether about the 38. I'm not in Discord. I heard from other people. Okay, so before I forget, I was about to give you the geometric interpretation of the partial derivative, which I forgot to give you last time. So suppose we have a function which classically let's say alpha, not classically. That's already made a mistake. Alpha is xy going to alpha of xy from R2 to R. So this means classically, this would be written as z is equal to alpha of xy is equal to, no, is equal to nothing. Never mind. Z is equal to alpha of xy. And so if I plot this, this is x, this is y, this is z, and there should be some sort of a thing like this. At any point xy, this is the value. So this is x, this is y, this is z. So this point will have coordinates xy, alpha of xy. So if you hold y is equal to constant, that means that you are intersecting this graph. This is the graph of alpha, what I've plotted. Okay, so if you hold y is equal to constant, that means I am intersecting this by a plane. So y is equal to k in R. So if this is the point 0, k0 here, that means you are erecting a perpendicular and it's the intersection of this plane. The plane sort of goes like this. That plane, so you look at here, you have, no, I should hold it in front of the camera. the XYZ, you have something like this, and this is y-axis. So if you intersect it by a plane over here, you get some sort of a curve, right? So you take at the point xy a tangent line to that curve, and the slope of that line would be the partial derivative at that point. So this will give you, this is the curve. So this is the point xy that I will have to choose xy differently because that didn't quite. So if you want to, that line will be the tangent to the intersection at the point of interest, and you can measure the slope. So we are thinking of, there's nothing over here. Okay. So again, so if you have, okay, this is so the del x of z. So since I'm holding y constant, it's only x that is allowed to vary, right? And that gives you the a curve. It will give you a curve, and the slope of that curve at the point xy is what the partial derivative will give. Okay, is equal to delta x of alpha. And let me draw another picture. X, Y, Z. So let's take some sort of a thing like this. And if I intersect by this plane, I am going to get some sort of a thing like this. So this is parallel to the x-axis. This is the point 0, K0. If I take the point xy is equal to xk over here and erect a perpendicular, then the slope of that line, which is tangent to that curve, okay, is what the partial derivative calculates. So now the question is that what is the derivative? The partial derivative basically intersects the thing with different planes so that it gives you a curve, and then the partial derivative of the function. That's a different question altogether, right? So this leads, so I will remind you again, the equation of a flat in flat form, that is y, if I call y the output, it is equal to some matrix M times X plus B. Last time we saw an example of this, right? So this M, which in the case of a function from R to R, a number, is actually what is the derivative. Okay, so the derivative will be this linear transformation. So given a map from Rp to Rq, how do I compute the derivative? First, that is a question. Secondly, how do I get the tangent flat to such a function at a particular point? Okay, so the physicist is wiggling one of those input things and wants to find out how some other output is wiggling. He's not changing the other stuff. So there are 15 inputs and 200 outputs. He's wiggling the 7th input and wants to know how the 109th output changes with respect to these small changes. That's the partial derivative. Okay, so but the mathematician is not satisfied with this question because the mathematician wants to know what is the derivative. Okay, now, so suppose we have, so the question in one dimension is like this. I have a curve. I have a point over here, X, or let's call that point AB, sorry. Yeah, A is a good A, 0, this point. So this is the point 0B. So this is the point AB. Okay, I want to find this tangent. Oh, it's a very bad drawing. Yeah. This is the tangent. Why is it not going to the point? Yeah. So how do I find the equation of that line? So I have to compute the slope. So compute the slope. The slope at that point, slope to, if this is y is equal to alpha of x, to graph of alpha at AB is dA of alpha is equal to d dx of alpha at the point x is equal to a, right? Which I can also write as d dx of alpha evaluated at a. So now that I know this, oh, I forgot your warning that I should respect the, but I will try to remember. Okay, so now the equation is very simple. It has to be y minus alpha of a is equal to d alpha of a at the point, sorry, x minus a. That's the equation to the tangent line. This is the equation to the tangent line. Okay, clear to everyone? Okay, to graph of alpha at x is equal to a. Note that this makes, well, this is also y minus b is equal to d alpha of a x minus a. Note that if I plug in a, the point AB in this equation, it satisfies it. Because the left side is 0, the right side is also 0. Clear? Okay, so now what happens if I have a more complicated situation? What's the general situation? The general situation, I have P inputs, Q outputs. Okay, so this requires that I understand my functions a little better. So this is an example. Suppose I have this situation. 3 inputs and 2 outputs. Y1, Y2, X1, X2, X3. So this is, we write this function as alpha, which is actually, I don't want to use alpha, I want to use phi. Phi for function. Okay, so phi sends x1, x2, x3 to alpha of x1, x2, x3 from R3 to R2. And alpha of x1, x2, x3 is a vector in R2, which means it has 2 components. This is alpha 1 of x1, x2, x3, alpha 2 of x1, x2, x3. Okay, that's in R2. So the output has 2 components, the input has 3 components. So now, whatever the derivative is, we would expect the tangent flat. So before I do that, so the graph of alpha is equal to x1, x2, x3, y1, y2 in R3 plus 2. I will write such that y1 is equal to alpha 1 of x1, x2, x3, and y2 is equal to alpha 2 of x1, x2, x3, right? I did respect the line this time. That's the graph. So how do we think of it geometrically? Geometrically, it means that you have a base which is three-dimensional, and you have a ceiling that is two-dimensional. So this is the base. And the graph is sort of like a tent whose base is three-dimensional and whose roof is two-dimensional. Clear? Okay, that's how you should think of it. Okay? Because in one dimension, what happens? You have, this is the graph. So the base is one-dimensional. The roof is also one-dimensional. If you have three dimensions, then you have an actual tent-like thing. The base is two-dimensional. I mean, I drew a wigwam rather than tent, but okay, I could have drawn an igloo also, or a house. So that's how you should think of it. So now how do I find, okay, so once this is clear, so if I want to find tangent flat to graph of alpha at A1, A2, A3, comma, B1, B2, which means A1, sorry. B1 is equal to alpha 1 of A1, A2, A3. And B2 is equal to alpha 2 of A1, A2, A3. Okay? Right, that much is clear. So now in the picture that I drew, I have x1, x2, x3 as the base, y1, y2 as the ceiling, and there's some sort of a thing over there. At the point A1, A2, A3, 0, 0, if I erect a, I mean, it's not a perpendicular, it's sort of going to be a two-dimensional thing that I erect. Where it would hit is the point A1, A2, A3, B1, B2. Okay, therefore I expect the equation to the tangent flat to be y1 minus b1, y2 minus b2 is equal to something times x1 minus a1, x2 minus a2, x3 minus a3. This generalizes the equation that we had before. Where did in this one, y minus b is equal to something times x minus a. But the point is, rather than being a number, it will be a matrix. Okay? So, yeah, that's all. I wasn't violent enough. So now, how do I find it? N. So on this side, I have two things coming out. So on this side, I have three things. So we expect something which is a, sorry. Okay, it will take an input from R3, but it should return an output from. No. Why didn't we didn't need that in the previous case either? There is the B is over there, it's hidden. But if you need the plus B, then you have just the X's, nothing subtracted from that. Y is equal to mx plus b would also be written as y is equal to m times x minus b over a. So what is the size of the matrix? It should have 3 columns and 2 rows. So it should look like this. Right? So M actually is going to be equal to del x1. Del x1. So how many components that just alpha have? 2. So this is going to be del x1 alpha 1, del x2 alpha 1, del x3 alpha 1, del x1 alpha 2, del x2 alpha 2, del x3 alpha 3. Okay? Oh, so this is all wrong. The alpha 2, I wrote out, this is 2. 2, 2. Okay? Clear? So we should get, actually this is written more concisely as del 1 of alpha 1, del 2 of alpha 1, del 3 of alpha 1, del 1 of alpha 2, del 2 of alpha 2, del 3 of alpha 2. Okay, so the equation will be y1 minus b1, y2 minus b2 is equal to del 1 of alpha 1, del 2 of alpha 1, del 3 of alpha 1, del 2 of alpha 1, del 2 of alpha 2, del 3 of alpha 2, evaluated the point x1, x2, x3 is equal to a1, a2, a3. You should look at the notes for how to write this down properly, because the tablet is not as wide as I need it. So, oh, it's far shorter than a piece of paper. x1 minus a1, x2 minus a2, x3 minus a3. Okay? But I mean, this is all worked out in the notes in great detail. So this is in the abstract. Now we should do a particular problem. Okay? So this is, you see, as you advance in mathematics, you will see that they just give you the abstract form. And then you have to make up the examples on your own, just as I'm doing. So I just make up whatever functions I wish. But since the algorithm is in my head, I can produce the desired result. But what is not, and that can be taught very easily. That I can even teach a machine by writing a program. But to be able to imagine it is something that the brain does. And that cannot be communicated. I really don't think it can be communicated at all. it's just very, very difficult. I mean, for instance, you heard a piece of music somewhere. How would you communicate to someone what the piece was like without actually singing it, humming it, playing it, or having a recording? Extremely sort of poor in comparison to the auditory experience that we have.
Communicating it without using sounds that represent
Yeah.
So you have to remove that ability for us to like make a random da or and make kind of reproduce that pattern. So how would you do that without doing that?
Yeah, well, that is exactly the musical score, in some sense, does precisely that. What is it? It's a graph. It's a graph of what? It's a graph of frequency against time. Although one doesn't say 3.2 hertz. Actually, what is middle C? Does anyone know? Riviera should know. Riviera in attendance? No. You should ask Riviera, what is the concert pitch now, let's say in Philadelphia? Philadelphia at the orchestra, it is a certain frequency. How many hertz?
So the Philadelphia
Philharmonic Orchestra. Concert pitch. Doesn't give you? Something Hz. Hz is the unit for hertz, a unit for frequency, which is hertz.
Four.
440 hertz. What is the normal frequency for human speech? What is the fundamental frequency? Anyone knows? 125 hertz. Yeah, that's the fundamental frequency of ordinary spoke. That means half an hour. Yeah. Yeah. You don't have to do anything. For that, we have to talk to IT, but IT is too lazy to do anything about it.
We could also just be
Crazy.
Yes. Yeah. So I am speaking somewhere around 125 hertz, between 100 to 200 hertz. And so, for instance, what does the fundamental mean? You know? Frequency of a sound. So a sound wave is a periodic function of time. So it could look like this. This is an aside. So so this is kind of thing with the sound wave. But this is actually in the vector space spanned by sine x, cosine x, sorry, sine x, sine 2x, sine 3x, up to infinity, and 1 cosine x, cosine 2x, etc. So you can write this down as an infinite vector by specifying the coefficients of the bases, which are the sines and the cosines. Okay? So that means you get an infinite vector in R to the n. So that's the representation of a sound wave. The lowest frequency over there is the fundamental frequency. Actually, you don't get x, we usually write it as 2 pi kx. Sorry, k is the fifth, yeah, or nu. 2 pi n, sorry, 2 pi k nu x. And the value of nu is the fundamental frequency. So when we see something, da, da, that is exactly double the frequency. So do to the higher octave do is double the frequency. So from do to the fifth is the frequency 3/2. So the Fourier analysis gives you a vector representation of a sound. And the proportion of the, the coefficients of the basis vectors, which I just specified, are the amplitudes of the resolved wave. That means A1, A2, A3 is the proportion to which the signal sine X is being multiplied. And then you add all of them together and you get this complicated wave. Okay, so the concert pitch is 440. We speak at roughly 125. As one grows older, one's ability to process higher frequencies usually declines. But it is only when you lose the ordinary speaking frequencies then that you have some difficulty hearing. Okay, so now coming back to what we were discussing, we now have to do a particular example. The reason for saying this will be clear later. Actually, this is more relevant towards the end of 272, when you will have to use Fourier series for solving certain equations. Okay. So this is a vector space of infinite dimensions, but we are dealing with a vector space of finite dimensions for the moment. So to continue with our example, let's take the following. Phi sends x1, x2. Or shall we do the same example? Let's do the same example so that. Oh. X1, x2, x3 going to x1 plus x2 plus x3, comma, x1, x2, x3. Yeah, so from R3 to R2. This, I'm doing this in the way in which I expect you to work. That means I made up an example in the abstract. Now this is a particular example. Okay, so I have now put in functions so that we can compute. So this is phi. It has three inputs, x1, x2, x3. This is y1, this is y2. Y1 is equal to phi1 of x1, x2, x3, which is equal to x1 plus x2 plus x3. And y2 is equal to phi2 of x1, x2, x3, which is equal to x1, x2, x3. Clear so far? So at x1, x2, x3 is equal to 1, 2, 3, phi of x1, x2, x3 is equal to 1 plus 2 plus 3, 1 times 2 times 3, which is equal to 6, 6. Right? Note that y1 is equal to phi1 of x1, x2, x3 is equal to x1 plus x2 plus x3. And y2 is equal to phi2 of x1, x2, x3 is equal to x1 times x2 times x3. Okay? And phi of 1, 1, 1, 2, 3 is equal to 6, 6. So, right? So find the graph. Not the graph, find the find the tangent flat to graph of phi at x1, x2, x3 is equal to 1, 2, 3. Okay, so you understand the question? So what is the dimension of the graph of phi? Dimension, okay, before that. Graph of phi is equal to the set of all x1, x2, x3, comma, y1, y2 in R2 plus 3, which is isomorphic to R5, such that y1 is equal to x1 plus x2 plus x3, and y2 is equal to x1, x2, x3. Right? Yeah.
So for in general, I want to consolidate my understanding. The x1, x2, x3 in 3 dimension is the floor that you were talking about.
Yes.
before.
The floor is 3-dimensional. It's not in 3 dimensions. Yeah, it's in 5 dimensions. In 5 dimensions. It's happening in 5 dimensions.
Yes, but the floor is 3-dimensional in 5-dimensional. So
Yes.
that roof is the 2-dimensional.
2 dimensions. Yeah.
Which is the x1 plus x2 plus x3.
No, which are the y1 and y2. They happen to have the value x1 plus x2 plus x3 and x1 times x2 times x3.
Okay.
It is all made up. So I'm just pulling it out of thin air just as I please. So if I were to lecture on this tomorrow, I will use some other stuff. Whatever occurs to me at the moment. Unless it may be specifically in response to something someone asked. So that's why this has a sort of spontaneous and what I should call a living that would never be there if I am writing up the notes while I'm in quarantine, or if I'm lecturing in an empty room. So this is the part that is gone if one is in this online setup, which I think is a very bad thing.
So and now we're looking for the tangent line. On
No,
the
not
point.
tangent line,
Plane.
tangent flat, not tangent plane.
Flat.
So I'm going there because this is the graph. This is included in R2 plus R3 plus 2. Oh, this is not 2, should not be right. That's 2 plus 3, but 3 plus 2. Because the input has 3 dimensions, which is isomorphic to R to the 5. Right? So this is happening in 5 dimensions. And the graph is sort of a tent, that is the metaphor that I used, whose base is 3-dimensional, whose height is 2-dimensional. So we are choosing the point 1, 1, 1 in the base, and the coordinates of the point precisely above it on the tent. The coordinates of the point is 1, 2, sorry, not 1, 1, 2, 3, comma, 6, 6. Right? So now I want to find a tangent flat at that point to the graph. So what is the dimension of graph of alpha? It is going to be equal to dimension of R5 minus the dimension of, not dimension, the cardinality, yes, number of independent equations. Right? So that's 5 minus how much? 2. So it's a 3-dimensional thingy. Okay? So the now we want to find the tangent flat at the point 1, 2, 3, 6, 6. And if this is a three-dimensional thing, the tangent flat at a particular point will have to be, if I have a circle, what is the dimension of a tangent to the circle at a particular point? Hmm?
Oh, circle with
A
the.
circle in the plane.
Oh,
Yeah, it's going to be a line. So if I have a circle in space, even then it is going to be a line. Sorry. If I have a circle in space, a tangent flat to the circle has to be of the same dimension. So it will be a line. If I have a sphere, it would be a plane. Okay. So now, how do I find the tangent flat? So the tangent flat, for the tangent flat, I would have to find the derivative of phi at first, the general derivative of phi, right? So derivative at x of phi is equal to derivative at the point x1, x2, x3. That's a very bad. x1, x2, x3 of phi I must have pressed in some way which produced this circle.
Turn it off.
No, don't turn it off. Just tell me what
So if you make something and you hold the pencil on the screen.
too long.
Make the shape that you.
I see.
thinks you're trying.
Okay. It thought wrong. So this is phi.
Doesn't have phi in its gallery.
Of course, it doesn't have phi in its gallery. Hmm? I could not understand what.
You have to pay a fee for.
I have to pay a fee for that one. Fee as in FEE. Yeah. Okay. So this will be del 1 of phi1, del 2 of phi1, del 3 of phi1, del 2 of phi1, del.
No, del 1 phi 2. Del 1 of phi 2, del 2 of phi 2, and del 3 of phi 2.
Just a moment. Del 1 of phi2, yes. Yeah, this is the part that I always get wrong. This is the second line. So phi2. Del 2 of phi2, del 3 of phi. Where?
Del 1 and phi 2, you put as del 2. So
Del, okay. Del 1. So now, this is getting easier and easier, of course. x1 plus x2 plus x3, del 2 of x1 plus x2 plus x3. What am I writing? x2 plus x3, del 3 of x1 plus x2 plus x3. Del 1 of x1, x2, x3, del 2 of x1, x2, x3, del 3 of x1, x2, x3. So that is equal to 1, 1, 1. x2, x3, x1, x3, x1, x2. Okay, so del, or rather d at the point 1, 1, 1 of phi is equal to 1, 1, 1 x2, x3, x1, x3, x1, x2 with x1 replaced with 1, x2, oh, not 1, 1. I keep on. One, two, three. 2x3 replaced with 3. So that is equal to 1, 1, 1, 2, 3, 1, 3, 1, 2. That is equal to 1, 1, 1, 6, 3, 2. Right? So, which one do I press? Zoom. Oh, I did zoom and it, so you will have to come to my rescue. Ah, okay. Ah, the icon of the pencil, yeah. So 111632. So the equation to the flat approximation to graph of alpha at 1, 2, 3 is y1 minus 6, y2 minus 6 is equal to, what was the matrix? 1, 1, 1, 6, 3, 2, x1 minus 1, x2 minus 2, x3 minus 3. And note that if I plug in 1, 2, 3 and 6, 6, it satisfies the equation. And it's a linear equation. Now, what is, if you want to put it in the form something plus b, you could do that, and there's no need to do that. That's a complete waste of time. Because what would you do? This is 1, 1, 1, 6, 3, 2 plus times x1, x2, x3 plus 1, 1, 1, 6, 3, 2 minus 1, minus 2, minus 3. So this is equal to 1, 1, 1, 6, 3, 2 x1, x2, x3 plus, this is how much? Minus 6, minus 6, minus 6, minus 6, minus 12, minus 9 is 21. Arash, do you see the B? But one is not interested in that. Okay, this equation is good enough. So now there are two questions. I approximated the threefold in 5 space with the 3 flat. Note that there are 2 independent equations in this case, right? One corresponding to the top and one corresponding to the bottom. So you can even write an equational description for it if you wish, by multiplying them. A completely useless exercise. Okay, so now this gives me the, okay, but suppose I say that so I have some sort of a function. What is the flat approximation to the function? That means I have x1, x2, x3, and I got y1, y2, y3, right? Y1, y2. So, so that means something depends on 3 unknowns and produces 2 unknowns. Can you give me a physical example of such a thing? No, 3 unknowns, which are independently specified, and what you're measuring are 2 unknowns. The output is 2 unknowns.
temperature, pressure, and volume measure.
No, the temperature, pressure, and volume in that case will have to be the inputs.
Yeah, there's record input.
And what is the output?
It will also be, and the output just be pressure volume. No.
Yeah, yes, but that would be a very silly experiment. You are specifying the pressure and volume, and then you are, and that's the identity. That's just a projection. No, it doesn't make any sense. The number of molecules is constant.
Well, I mean, let's say like, if you want to like.
No,
know
this is just completely wrong-headed. Think of yourself as a system and think of something, three things that you take in as an input. Food, water, and oxygen. Okay, so you measure the amount of food you take in a day, measure the amount of water that you drink a day, and measure the amount of oxygen that you breathe in a day. And what are the two outputs?
Urine.
Feces. Okay. Okay. That is a perfectly fine system. In fact, this is the kind of thing, precisely the kind of thing that would be done in a good medical setup. Does anyone know the amount of urine that one produces a day in liters?
I would say, I would estimate.
No, there's no estimate. Either you know or you don't. Now we have Google the omniscient.
Never counted.
The counting would give you the frequency of urination. No, you have to measure the volume. Yes. Can't count the volume. How many liters or milliliters would be the correct unit?
800 to 2,000 milliliters a day.
Okay. And what is the total amount of feces that a human being produces per day in grams?
I would say 500.
It's also,
Google doesn't know?
I just don't learn defecation.
No, you can't say defecation because defecation is the act of producing feces. FECES.
Um,
120 grams. You estimated it, you estimated 5 times as large. So that,
But for water, I wasn't what I wanted to say 100%.
yeah, but on what basis? If these are the things that you should know about yourself.
Well,
So
I guess the density of
100 grams. That's how many grams? 128. That's the mean. That's the mean. What is this?
Yeah, but like you can go take food and weigh yourself, and usually it's a pound difference. That is a pound is
2
pounds.
No, a pound is 1 over 2.2 kilograms.
Yes, yeah.
1 over 2.2 is 0.5.
It's about 0.5. What I'm saying is that it looks like it's like that gram amount doesn't seem like
And it's the average throughout the world.
the accuracy of the scale. But that could be.
Anyway, but you see that this is a good system. In other words, this is an example. You see, but you think that this is silly, but the point is there is a disease called nocturia, which means frequent urination. That occurs to both men and women. And in that case, the amount of urine produced is larger than usual. So this mean doesn't tell you anything at all. You really should know the distribution. You should also know the distribution as a function of time over the lifetime of an individual. So one of the worst things about the United States healthcare system is that there is no talk whatsoever of prevention. If you are all studying the sciences, none of the questions that I ask you about your own body, you have the faintest idea about, which means you are really illiterate with respect to your health. That means there's something profoundly wrong about the educational setup.
What would the expectation system to make the students know how?
Make everyone know, not just students, because the body is what you're born with. If you do not know your own body, then other people will take advantage of you. It is happening now. In particular, the culprits are the insurance companies. So if the idea was to prevent disease, one would know what these parameters are. And one would measure them regularly to see if there is any sudden change, which means we have finished now. Yeah. So which means what? If you plot the parameters on a graph, the one that we just did takes somewhat literally the word input and the word output, but it will give you exactly something like a function that I just said. Its derivative should be roughly zero if you are a stable system. They should not change too much. Do you understand what I'm saying? Yeah. But it would show some systematic variation throughout one's life. And we could actually use this information to judge, to get a crude estimate of the state of well-being of a person. So now let me point out some other kinds of things that are measured. Cholesterol in the blood. Right? Yeah. What unit is it measured in? Yes, but if you have it, but you don't know what the value is and what the units are, then again, you see, this is what I find very strange among science and engineering students. You really should know. How many of you know your blood type? And if you have an accident, will it help anyone if you have forgotten? Okay.
Universal donor or universal?
That's neither. O negative is universal.
Yeah, O negative. I can only donate.
Well, no, and O positive universal, exactly.
No, AB positive.
Universal recipient.
Yeah. But at least it's not as bad as I thought it was. You at least know you are not saying X and PQ. You at least have the right names. You must find out. You can't be a science and engineering student and not know the basic information about your own body. So find out. Find out, and if you really want to help people and yourself, you should produce a program that takes, or find out what, if you have a comprehensive check up all the things that they measure. And then you can plot them against time. And you can also set the range. So if I consider my own values, they will give you a time distribution, right? It will change with time. And if it fluctuates too much, it means that something is going on. Because normally, the body should be a stable system. So for instance, let's take another thing. Does the blood pressure of a person remain constant throughout the day, or does it show variation? Do you know what kind of variation?
I mean, depends on like your feeling activity. Also what you're eating, there's a lot of variables.
So this is a function of multiple variables. But what is what if you say that this is normal, what is the graph? Diurnal variation of blood pressure. Put it in and see what Google gives you. In a normal male in the age range from 15 to 30. Have I included everyone? Yeah, diurnal means throughout the day. Yes. Graph.
Yeah, you got to-
Blood pressure versus time. You have to turn the computer to show me because I can't see.
Yeah, it slightly goes up because
Let me see.
Yeah. All of this stuff. It's here.
Okay, these are actual plots, right?
Yeah.
Yeah, so this is not going to give me any, okay, yeah, you can take it there. So if you, yeah, the problem with these pictures is that they do not show you a continuous curve. They show you a dotted curve that has been joined piecewise with piecewise linear pieces. Yeah. It is not, it is a function.
Oh, it is a
Of course.
function, but it's like,
It is an approximation to the actual shape of the function.
it's not like a function.
It is continuous. It is not differential. It is not smooth.
It's not different.
Yeah. So this,
So what you're saying is it's not something like that.
yeah, that's the better one. Yeah, you see? Can you send that to Max, that picture, so that he can put it on the,
I can put it in Discord.
yeah, put it in Discord, but send it to him. If he can put it in the video, that would be very good. Is it possible? Yeah. But look at the curve. That is the curve that is of interest to us. Blood pressure versus time. Okay, so if blood pressure versus time behaves abnormally, that means something is wrong with the heart. What is the heart as a physical object? It's a pump, essentially. What are the lungs as physical objects?
They are below.
No.
I,
Who is the mechanical engineer? Well, what is it like? There's a machine where you,
Mix of valves, pistons.
no, where you press on something and it produces yes, it's a set of bellows. Yeah, if you go through an ironsmith, you will see someone pressing on a device that contains air. Yes. But the tire is not part of you. So, do you understand this now? You really need to know these things. So now, the blood pressure, you see the blood pressure, the diurnal variation blood pressure gives you a graph. It's a, where is the graph? So it's the diurnal variation of blood pressure gives you a graph which is pressure versus time, right? Pressure versus time. But if you consider the curve itself over the lifetime of an individual, then that curve will change shape, right? So the derivative should be as close to zero as possible in the rather technical sense of how the curve is changing over the lifetime of an individual with respect to time. Doctors don't do this yet. They have just these numbers. But the object would be, if any of you go into biomedical engineering, which I hope some of you do, the object would be to find an ideal description of a pump which has these characteristics and see how it should behave in an ideal scenario. So it will require you to be able to program, because you would like to see with input data how it is going to behave. That brings me to two things. Even though I digressed quite a bit, I am a little shocked at the lack of direct awareness of realities that affect you physically. This is not a good idea at all, to be completely unaware of one's own body. It is extremely important to understand your own body as a physical system. In the West, under the influence of the church, there was a very strong, what should I say, prohibition against educating people about their own bodies, which is sort of evident from a variety of observations, of which the experiment that I just performed is an example. Yeah. So you must understand each of your organs very, very well, in particular the sense organs. Okay. And as I said, that you tell me. But name some of the ones that we are. Yes.
Well, that sense of hot, sense of cold, sense of carbon dioxide, sense of time, if you want to put that sense.
Yes.
Sense of hearing, which is where balance is also at. Sense of smell, which is probably two different senses at least, because you have two noses, you have two nostrils. Not for the
You
fact-
don't have two noses.
You have two nostrils.
Yes, yes.
You have two nostrils, not for the fact of the location of the air. You smell more. One of your nostrils is always breathing air at a different rate than the other.
Yeah, actually, yes. And in fact, the breathing changes periodically.
Yeah, it flips back and forth.
Yes. Yeah.
And your sense of taste, which is broken up into what are the five flavors? Umami, sour,
Sour, sweet,
sweet,
hot, bitter. Yeah.
Is that a taste? I know.
What?
You're getting her.
Yeah.
Hot. No, hot. Hot is what the Americans call spicy.
Spicy.
Of course, it is a sense of taste.
Well, what do you mean? It's actually your tongue burn.
Yeah, it's an intensity thing. Spicy.
No.
There's supposed things that have very specific tastes.
Yes.
You can-
The words used to describe these sensations are very crude compared to the actual physical processes that go on. Yeah, that's in English. If you go and learn Japanese, you will see lots of different words for taste which will not correspond. Not just unami, that is because you know about the Japanese taste of monosodium glutamate, that is the monosodium glutamate industry. In Indian languages, there are many more words for taste. You excluded sour, for instance. Yes.
No, not bitter. I said sour. We have sour, bitter.
There's also a caustic taste. When you eat something which is unripe, an unripe fruit, for instance, persimmons very often give you this taste. Caustic or astringent. Persimmon? Yeah, it's a fruit. It looks like, and you can be fooled into thinking that's a tomato.
Oh.
It's very common in Iran. Yeah. But you see, the point that I'm trying to make is that all these are objects that in principle could be measured. and your well-being, and they change the ability to make recognize subtle differences changes as you age. Okay, so physical well-being can be quantified if we could measure these things and thought of ourselves as systems.
Even the people who like devote their whole lives to it, it's still like there's a lot of potential of like nutritional science and stuff. Like obviously,
Because it's not a science anymore. Because it's not looked at. It's not looked at in the proper way. So because one of the features of science is that there should be idealizations, which ignore the irrelevant details, but look at simple objects whose properties can be studied using geometry and physics in detail and with a kind of completeness. So in order to understand how the moon moves, we can assume it to be a particle, which it isn't. It is extended, right? So that's the kind of thing that is lacking in biology. I mean, we do not understand the physics of a cell. There are many questions to which we have the faintest, and we just do not know the answers. In fact, we do not have the faintest idea about the answers. Also, we do not understand the sense of texture at all. And in fact, the fact that we have very few words, and we can say coarse and smooth, there aren't very many words. Fuzzy, yeah. Soft, hard, but not very many words. Bumpy, yes.
That is weird. That is weird. Because what is the weird one? The weird part is.
But the question is the following. How would you?
Here's the thing.
But it's a very bad idea to lick something in order to understand the texture. As children. Yeah.
Yeah, these like taste mercury.
Yes, well, I mean, I did that also in chemistry, because there were 12 different radicals that we had to identify. And I thought if I knew the answer before I performed the experiment, then the chances of getting wrong are reduced enormously. So I used my primitive sense organs and thereafter did perform the experiment.
So as babies, we're used to lick everything.
Yes.
So one of the reasons it's like, you know how it feels like to lick like a pot, like wood, but without licking it. Because in our brains, we know like it's already recorded.
Which one knows where everything feels like?
Exactly.
This is not entirely clear. Anyway, but this is a more difficult question. Let me finish the.
We got a very more tangent there.
No, but it is very important because the point is to make you proper scientists and not people without any understanding of their own bodies. This I think is very bad. Well, yes, in this instance, we are in a state worse than a cabbage. Okay, let's see. So we found, so what is the, we have to write this in the form of a flat approximation. So, not a flat approximation to the function. Okay, what would be, so we want to replace the function, which is certainly not linear, by a flat function. So how do I produce that? So the flat approximation, the notation that I'm using over here may differ from the one in the notes. And you should always use the one in the notes because this is something that I'm making up right now. Okay, flat approximation to phi at the point 1, 2, 3. Should be some function, but what does that function do? It sends x1 x2, x3 to what? To y1, y2. But you see, I don't really know what y1 is until I solve this completely. I have only a little bit left. So can I multiply and tell you? Y1 is going to be equal to 6 plus x1. If I make a mistake, it is your fault. Minus 6. From here, from the left side. And y2 is equal to 6 plus 6x1 plus 3x2 plus 2x3 minus 21. 21, that is equal to 6x1 plus 3x2 plus 2x3. 21 minus 6 is how much? 15. Okay, so this is going to be equal to x1 plus x2 plus x3, comma, 6x1 plus 2x3 minus, plus 3x2. Sorry, that's something I wrote something wrong. Let me erase. X1 plus x2 plus x3, that is fine, comma, 6x1 plus 3x2, 2x3 minus 15, going from R3 to R2. I can't really fit it in, so I'm writing it below. So note that the first component was already linear. So its flat approximation also turned out to be linear. It didn't change, which is what is expected. And the second coordinate gave something which was non-linear, and that changed. But now the whole thing is flat because you have linear expressions. Okay? First power with exponential x3. So I will stop here for a moment. Do you understand this? The procedure.
I do not understand how this is here.
It is a linear approximation because the equations which describe the graph of, it's a flat approximation, not a linear approximation. Graph to the flat approximation of P, did I write phi or alpha? The phi at the point 1, 2, 3. One, 2, 3 is equal to the set of x1, x2, x3, comma y1, y2 in R3 plus 2 such that y1 is equal to x1 plus x2 plus x3, which is exactly what we had. And y2 is equal to, please read it. No. That was the graph. This is the graph for the flat approximation. 6x1 plus 3x2 plus 2x3 minus 15. So this is, the flat approximation is defined by two linear equations. No, it was we found the tangent flat to the graph of alpha. And we also found the flat approximation to the function. So the function sends x1, x2, x3 to y1, y2. But it's a nonlinear function. This is an approximation to the function by a linear function. Okay, so let me give you an example. Suppose I have a function like this, and let's say this is temperature versus time. So I have this value of the temperature now. I want to know the temperature over here. So I can go along the tangent. That would be better than going along the horizontal line. Clear? So this is a slightly better way than what we had previously. So now you have something where this, I'm drawing this, something like this. So these can be changed. And these two are the dependent elements or the observed. These are the ones that we specify. These are the two that we observe. So, oh, the ruler appeared and I made the, how do I make this disappear?
Hold down and just swipe it to any side.
Okay. So now we have some sort of a tent over here, right? So to be very specific, we will say that these three correspond to, what was it? Food, water, and food, water, air. These are the intakes. And these two was the feces, amount of feces per day and amount of urine per day. So it's some sort of a graph. So I know the values for today. Oh no, there's another element over here. It's time, which we left out.
We have to.
Okay, so this, I mean, I can't use this immediately, but I can do something. Okay, wait. So let's say this is the graph. Oh, what happened? Click on the 3 lines on the right. Here. Where's the magnifier? I can't see the magnifier. Ah, okay. Yeah, this one. So we can't, so the independent unknowns are the food, water, air, right? So let's say that we change the intake slightly. So I have the graph, but I change the intake slightly. By how much will the amount of feces and amount of urine change? It's plus slightly. Will change slightly, we hope. And so that can be measured by going along the flat approximation. Sort of what we did over here. We went along the tangent and took these values. Here too, we can go along the tangent, along the flat approximation and get those values. And the next part, of course, there's an analog of the Taylor formula, where you don't just go along the tangent, but you take higher derivatives also. That will be in the 3rd exam.
So what do you have to draw the graph? Like after certain inputs.
The graph sits in 5 dimensional space, and it looks like a tent. And the bottom of the tent is a 3-dimensional object. The roof of the tent is a 2-dimensional object. So you are moving on the base of the tent, which is 3-dimensional. So a point in the base is the amount of food, water, air. So if you change those slightly, then in the roof of the tent, the point should move slightly. So you want to get an approximation for where you would go, because you just have the data from one particular input. So you go along the tangent flat, and wherever it hits the curve, sorry, not hits the curve, wherever you go along the tangent flat, that is your expected value of the amount of feces and amount of urine.
So what says it's 2 input, 2 output?
No, 3 inputs, 2 outputs.
2 output.
Yes.
It's like a 2-layer ceiling, right?
It's a 2-dimensional ceiling. You have to imagine it somehow, not 2 layered in any.
It's 2 kind of time.
Yes. So to specify something on the ceiling, you need 2 numbers.
There are 2 further approximations. Like a straight tangent one approximates the curve.
Yeah.
Oh, I really was wondering.
Yeah.
You saw his, email.
Oh, yeah, if you saw his email, whether questions 3A and 3B was supposed.
Yes, I did see his email, but I didn't have a chance to respond. Okay. Okay, so let me pause. And so this is quite a bit. So the question is whether you have some rough idea.
Kind of like this three-dimensional thing that then defines a two-dimensional.
Yes. And which is curved, and we don't really picture it very well. And we know what the output is here, but we want to know the output here. So since the whole object is very complicated, if I know the flat approximation, we can use that to estimate. Is this idea clear? What is the most important operation on functions? The most fundamental operation on functions. No, equality, of course, but given two functions, the operation, equality is not an operation on functions. Equality is a predicate defined on two functions. Given two functions, you can decide whether they're equal or not. But if you have two functions, how do you produce a third function out of the two? Well, you may not always be able to add functions. You see, suppose one function goes from R3 to R2, another function goes from R2 to R3. You can't add them. What is the... A function is not a set, so it doesn't make any sense. No, two functions are equal, which I have defined. If the sources are equal as sets, if the targets are equal as sets, and if the graphs are the same, that means they have same output for the same inputs. So you can intersect the graphs of two functions. You can't intersect functions because functions are not sets. No, functions are not sets. I mean, a graph of a function is a set of function is a different kind of object. So you're making a typing error. But this is very bad. What can you do with functions? Well, what is the grown-up word for that? Composition. Composition is the most important operation on functions. But you can't always compose two functions. You can compose functions only if the set of outputs of one is equal to the set of inputs for the other as sets.
Or it's like a subset. Equal or...
No, subset, we didn't consider that situation. We just deal with the situation in which they are equal. Okay, so now remember the chain rule. The chain rule is the formula for the derivative of a composite function using the derivatives of the individual functions. So the next question that we shall address is what is the form of the chain rule in many dimensions? So you have a function going from R3 to R2 and another function going from R2 to R7. I have taught you how to compute the derivative of this one and the derivative of this one at particular points. What is the derivative of the composite function? So that's the question that we are going to address. But before that, first, let me discuss composition. So suppose I have a function x1, x2 going to y1, y2, y3. And this is phi, this is alpha. And this is beta, which takes x1, x2, x3, and goes to y1, y2. Of course, we could. So this is just the setup. So note that if I first do beta and then alpha, Then beta has how many inputs? X1, X2, X3. And we will call these Y1, Y2, Y3, which means here I have to call them something else. So we will call them Z1, Z2. This is alpha composed with beta. Note so alpha in functions from R2 to R3. Beta in functions from R3 to R2. So alpha composed with beta is a function from R3 to R3. Beta composed with alpha should take, okay, I have to erase this. What is the time now? Has it 7:03? It hasn't gone off yet? Ah, yes, because he went to the bathroom probably. Okay, so if I first do alpha and then do beta, then I take two inputs, X1, X2, which gives me three outputs, and then again two, which I will call Y1, Y2. This is Z1, Z2, Z3. This is beta composed with alpha. And beta composed with alpha is a function from R2 to R2. So first thing to note that alpha composed with beta, beta composed with alpha may not be defined. Okay, and even if they are defined, they need not be equal. Okay, the inputs and outputs have to match up properly. So this is a very dangerous situation for type checking. And many people just say things which are absolute nonsense. So let's compute a composition. So let's say alpha sends X1, X2 to X1 plus X2, X1 minus X2, X1, X2. And beta sends X1, X2, X3 to X1, X2, X1, X2, X3. So if I first do beta and then do alpha, what would happen? X1, X2, X3 will go to X1, X2, X2, X3, right? And then I should get three outputs. What are these? X1, X2 plus X2, X3, X1, X2 minus X2, X3, and X1, X2 times X2, X3. If I did it the other way around, first if I did alpha, so it had two inputs, X1, X2, it would give me three outputs, which is X1 plus X2, X1 minus X2, X1, X2. If this is beta, that would give me X1 plus X2 times X1 minus X2 and X1 minus X2 times X2, X3. Is the mechanics clear? Okay, so now the question will be that if I know the derivatives of the individual functions, how do I find the derivative of the composite function? Okay, so that means I will write the formula down. D at the point X of beta composed with alpha is, so these are vectors, so just a minute, is equal to d at the point alpha of x of beta times d at the point x of alpha. That's called the chain rule. So note that you can either compose the functions first and then compute the derivative, or you can compute the individual derivatives and then multiply. Hmm? No, on the left side, we have composed them. On the right side, we first find the derivatives and then compose, then multiply them. Composition of linear maps is multiplication of the corresponding matrices. So there's a problem on the exam where you have to compute both of them and show that they're equal. Okay? Is this clear? And so I hope some of you go and become doctors and have a strong computer science background, so that all the things that I'm talking about, which don't exist at the moment, you can actually construct. That means you can construct idealized or you can construct idealizations of the human organs. And then you can study them as physical systems. And your goal should be to produce on the basis of calculations, the kinds of things that are observed. For instance, the diurnal variation of the blood pressure. In other words, the things in which you have no interest. So you have a machine, and Byron's example of which takes in nutrients in 3 different forms: food, water, and air. And then there's the excreta, the feces, and the urine. And the question is whether if you know enough about the machine, can you weights and volumes of the objects taken in, calculate and come up with the amount that should be produced for an ideal machine. So note that in the case of physics, if I know in the case of an ideal gas, if I know the pressure and volume, I can predict the temperature. So I'm asking you to do something of this kind. It doesn't exist. It doesn't matter. Mathematicians can talk of infinitely many variables, as in the case of sound waves. There are infinitely many variables. So how many of you have equipment that play music? Oh, you have, I didn't mean a musical instrument. I meant something on which you have laptops. Okay. Okay. So laptops, how is the sound? You don't like it. So what alternative do you have?
Oh, my headphones, I think they have better bass.
Okay, you said they have a better bass. Okay.
Compared to the laptop.
Okay.
Okay.
And earlier, before laptops existed, people used what sort of objects? Phonograph is in very ancient times.
Before.
Yes.
Record
You
player.
have better speakers, but as TV become thinner.
Yeah.
Their speakers, some of their speakers become worse.
But so you are using descriptive terms. How do you, suppose you want to buy some sort of a device that reproduces sound? What qualities would you look at? What does it say? Something is there's a word that people used to use. It rhymes with Wi-Fi. Hi-fi. What does hi-fi mean? Okay. Fidelity, what does the word fidelity mean?
Quality of the sound.
No.
Cover is more frequent.
So what's the use of knowing a word if you don't know what it means? It doesn't matter, but you have objects. No,
So it has less distortion. compared-
yes, those are words. What does it mean physically? You have to answer from the perspective of someone who has taken 270. If you fall short of that ideal, then you don't know what you're doing. What's the point of learning 270 if you don't know what hi-fi means?
The sound is accurate then.
What does it mean? This is simply empty words. I just told you what a sound is. A sound is a vector in an infinite dimensional space. What does the word fidelity mean if you take it out of this context? In general, what does it mean? Where else is it used, the word fidelity? Relationships. What does fidelity mean in the
Faithful.
Hmm?
Faithful. Means faithful.
faithful means that one is true. Okay, so truth in the case of sound reproduction should mean what? That the sound that you hear should be, in some sense, equal to the sound that was used as the input. Okay, but what is something that people like to do? There's a knob which you turn, raise the volume. Okay, so the question of fidelity has to do with how the sound changes if you increase the volume. So if you increase the volume, sometimes the sound would be perceived with a certain amount of distortion. What does distortion mean in this case? So the input sound is a vector. So I told you that the basis vectors are 1, cosine x, cosine 2x, etc., and sine x, sine 2x, etc. So the components are, let's say, A1, A2, A3, etc. When the volume has to do with the amplitude, that means this A1, A2, etc. Not the amplitude, but it's the square of the amplitude. So if you have what is it called? If you have a microphone that increases the volume, right? So it is basically the amplitudes will be squared. So if you have the vector, let's say 2, 4, 3, its amplitude vector is 2 squared, 4 squared, 3 squared. Okay, so the ratio of the amplitudes, which determine the quality of the sound, cannot remain the same if you square them. So an amplifier has to be designed in such a way that the response is flat. That means if you change the volume, the frequency ratios remain the same. So this is not easily achieved. It requires an enormous amount of engineering. So if you buy record players, you will see that they usually give you a graph with a frequency range. And the response of the amplifier is flat. That means it does not introduce the vectors that are input. Even if you change the volume, the output would be the same.
How do you know? How would you know? Well, there's no extra amplifier or like that.
No. It gives you a composite response. So the input has a certain fundamental frequency. So it is plotted against the fundamental frequency. What is roughly the range of frequencies that human beings can hear? Between 20 and 20 hertz and no, 125 is the normal frequency, fundamental frequency of ordinary speech. One can hear from 20 to 20,000 hertz roughly. Okay, so this is a very large range of frequencies. So the individual basis elements go on towards infinite frequency, right? Because you have first nu, then 2 nu, 3 nu, etc. in the basis vectors. So if different frequencies are amplified by different amounts, the sound would sound distorted. So you have to amplify them by the same amount. So you have to use different kinds of amplifiers in different regions so that this is achieved. Okay, so this is not an easy task. But if you buy equipment and if it is supposed to be high fidelity, you should know what it is actually doing. I mean, I can just come and say, well, you have X and I have this wonder medication called abracadabra. Give me $7 million and I will give it to you and you will be cured of whatever X is. I mean, you wouldn't believe me. But all of you took the mRNA vaccine, I suppose. Pfizer or Moderna. Do you know what it does to your body? Did you even try to find out? Or did you trust the CDC?
Did I not have the option for to kick out of the military?
No, there were
Yes.
certain choices. No, there were 3 choices in the US.
No. Did I have the option to take it or get kicked out of the military?
No, there were 3 options given.
What's the third?
Johnson & Johnson.
No. My options. Take one of those.
Which
vaccines
the
or get kicked out of the military.
No, there were 3 options given to US citizens. You are a US citizen.
Okay.
So Pfizer, Moderna, and Johnson & Johnson. Yes. So of these, how did you decide?
Because the one that was available at the time.
Did they say that you have to take this at the base and only one of the ones that are available? This is impossible. The military cannot give you fewer options than an ordinary citizen. So if you insisted that you had the Johnson & Johnson, you could have got it. But that requires that you find out about these 3. Did you? You actually have the right to find out. But if you don't exercise this right, that means you are allowing yourself to be led along a garden path.
So you were allowed, yes. So I didn't think we want to do Johnson Johnson to.
But someone is sticking a needle and putting something inside your body. It's your body. So shouldn't you be concerned? But why weren't you? But then why didn't you find about the articles are available on public? No, the doctor may be in the pay of the military and may not give you the. Yes, that is already a bad move.
Oh, you're saying.
There is a conflict of interest. So you go and find out from independent sources what it is. What's the point of learning statistics? You can, the Lancet article was available to everyone. The Lancet article about Pfizer's findings. I sent it to the entire department because I wanted to know what kind of study they had conducted. And the study leaves a lot to be desired. It doesn't require more than very basic understanding of statistics. If you don't exercise your rights, in that case, you will be fooled. You are learning higher mathematics. You know more mathematics than what your superiors who give you orders know. It is in your... But
There's a lot of like.
I understand, but that the first step is actually to look at what data has been provided and then ask yourself, where do I see the holes? If some organization is pushing 2 vaccines and the profit is connected to their own pockets and something is being pushed aside, then I would be immediately suspicious.
I mean, I got it.
You did a good thing. We shall find out what happens to you in 10 years.
Yeah, I'm in the same boat. Fair enough.
I got really want me to give it or not.
Anyway, but the most important part is that if you information is not being hidden from you, you have right to the information. If you don't exercise the right, then you are playing into the system. Hmm?
The information was given to us. And we got it.
Yes, but the information that was provided to you didn't look at. It doesn't really matter.
But this information we heard or told was
Yeah.
a lie.
That is true,
So
but
even
that
if
the
we
study,
listened to it,
no, that the study was flawed was immediately clear to anyone who looked closely. The Lancet study that Pfizer published, the first one that came out when, yeah.
that it can prevent transition. That was
No, there, you should go, okay, I will send all of you the Lancet article. So you read it, and then the damage is already done, except in his case.
I specifically didn't.
At the time, that was the one they were saying was bad, which, you know, maybe I don't know, but, I remember there was some.
Did you,
interview with
why
them.
did they say that that was bad? Why are you
I
using the
forget
bad?
the exact, it's heart failure or something like that.
Well,
It was-
did you go and see the sample size?
It was very small amount of people.
Yes.
So I think the sample, like, the reports that came out, they weren't. like,
Are you a
experiment.
menstruating woman? These were the cases in which it caused trouble. So if you're not a menstruating woman, in that case, it shouldn't be applied to you. Okay, yeah. What time is it now? 23, okay. We have covered a very large area. Okay? Yes, so now shall I stop the recording? Where is the, oh, I have to end first. And the people